Just get started with the smallest thing, and then once you get the first thing done, you'll like snowball into an effect, and then you just become unstoppable until you hit a wall. And you're stuck there for 3 days, right? My name is Abdulmalik, and I'm a software developer at Tierra.
What's the longest amount of time that you've spent coding without a break?
In one session,
Yeah.
I've done like 6 hours at a time sometimes. I mean, like, actually not, maybe not 6 hours, but it can happen. I try not to do too much because it can, number one, strain your eyes, not good for you. And number two, you get stuck, man. If you like sit in one place and do the same thing for a long time, you get like kind of, you're almost like facing a wall. So it's good to like change up your environment, go out for a walk, walk somewhere. It's called rubber ducking, by the way. This is a very well-known phenomenon in programming. So rubber ducking is essentially like when you take a break from the problem that you're solving, you go outside for a walk, and then somehow during that walk you get like a wow, okay, like an epiphany, right? And you come back and you fix it. It's called rubber ducking. So like you solve the problem that you're trying to fix, not on your desk, outside when like you're being outside in nature. I don't know where the term rubber duck came from, by the way. It might be just something that they tossed.
When you first joined us, the first thing you said about a piece of code that we inherited was we should apply ESLint.
Yes.
Can you explain what ESLint is?
So ESLint is a code formatter. So it's basically just standardizes the way you format your code. So one of the problems, or one of the things that I saw was that a few imports and a large number of files were not being used, and I just thought that was weird, because to a person reading the code, like myself and the other devs, like it wouldn't make sense to have something that's not used be included in the file. So just get rid of it, right?
Right.
Yeah. So when you implement ESLint rules and you enforce them every time there's a commit or whatever, like we try to do, and you really increase the speed in which other devs and yourself read the code, and for you to just sift through it, because just when you have a lot of extra stuff that's not relevant, it's like it just takes up extra time that shouldn't be taken, and then just go from there, I guess. Linting is essentially like formatting and standardizing the way you write code in terms of the small, minute stuff that just makes your life easier, and like establish a convention so that everyone else can follow it, and then the repo becomes standardized and easier to go through. That's the idea behind it. Just make our lives easier, quality of life.
Yeah.
Exactly, yeah, that's exactly the point of ESLinting, is to make my life and the other devs' life easier, and the devs that you pass on this project to easier. Because at the end of the day, you want to do something where you find the campsite, you clean it up, you put it in, you leave it better than you found it. That's the idea that I got taught when I was doing this, when I learned this kind of stuff.
Tell me about how you tackle a brand new API that you've never worked with before.
Oh, first start out with like curl requests, man. You just like throw a bunch of requests to different endpoints, see what happens. But that's the kind of throw spaghetti at the wall, see what sticks kind of approach. But if there's documentation, obviously just use the documentation. Makes your life a whole lot easier. But yeah.
Do you have an example of, tell us an example of a new API you've never worked with at Tierra.
Okay, I'm working with Vonage the other day to integrate WhatsApp to allow us to send WhatsApp messages through Vonage API. So it wasn't particularly difficult because Vonage has developers in mind, so they designed their product in a way where it makes our lives easier and much faster to integrate this API into our existing products. And the response structure and the request body is like very simple.
Tell us how AI works.
AI stands for artificial intelligence. It basically is any sort of intelligence I say here, or any sort of solution to a problem that is solved by a computer, if that makes sense. So for example, if you create a calculator app which asks you what's your first number, and then asks you what's your second number, and then spits out the sum of those two numbers, that's technically artificial intelligence, but on a really simple scale. The current AI that we have in the modern day is that, but just exponentially exploded into like probabilities and so much other stuff. When we want to talk about probabilities in AI, the way it works is that it's all perceptrons, which are basically neural networks, artificial neural networks, that you have weights and biases within these neural networks. And then based on the inputs and that you give to these neural networks, you'll get some sort of output, and based on this output, you might be able to deduce something that could be beneficial or like could be related to the input, but yeah, but most of the time it is based on how well you train the neural network, and then you'll get a better result based on how well trained it is. If that makes sense.
Tell us about embeddings.
Ooh, embeddings are an interesting thing. So when you have two pieces of text, say you have "I love my cat" and "I love my dog." These are two very similar sentences or phrases, but they're not exactly the same. So when you talk about embeddings, it's essentially a way to represent these words in number form, in something that you can call vector space. So you have, imagine you have a graph that's X and Y, and the word dog might be like here, and the word cat might be like here, and the word pet might be like in the middle somewhere. So they're all like closely related. And in natural language processing, and now with LLMs that are coming up that are getting ridiculously popular in my opinion, you can use this embeddings to determine how good of a response the AI is giving you in relation to what you'd expect it to. So you'll have like an expected answer, which is basically, let's say you ask the AI a question, what's whatever, like 10 plus 10. So you'll expect it to write 20, right? Maybe this is in like 2, 0, literally the characters 2 and 0, or it could write 20 in letters. In vector space, based on how good the embedding models is, it should know that these are very similar and should tell you that, okay, it should give you a close enough answer. I mean, the one should give you a close enough response, a good enough score to determine that this is, okay, accurate enough to be determined as correct. If that makes sense. And that's basically embeddings in a nutshell. So currently we're working on a natural language to SQL query generation workflow, or workflow you could say. And then this workflow would basically will consist of a few agents that will, number one, generate the query, check if it is correct, if the intention of the query is correct based on the generated one, and then check if it's optimized. And if it is optimized, propose a new optimized query. And then a final agent that concludes if this query is accurate, optimized, and good enough, or no. So you have these four, and then you can have, and then what we're doing, how we could use embeddings in this case would be to have a list of data, create a data set where we have natural language prompts and expected outputs, expected queries, right? And then we'd compare we'll send each prompt through the workflow, and then compare the generated outcome with what we're expecting using something called embeddings. And this is where you can get an idea of how close or how similar answers are in vector space, in how similar these SQL queries are in vector space, I guess. In the Connect, let's say a user sends a query or a message to a business, right? So they're asking, hey, I want to buy the largest size smoothie that you have, right? So it'll fetch, we need some sort of, and this smoothie is available in our database. And in order to query the database, we need to generate a query. But the thing is, the query might be different every time, right? So how we do, if we don't have that query already cached somewhere, we'll generate a new query through this pipeline.
Right, okay, so that basically means that if someone says, I want a large smoothie one day,
yes,
and then another day they say, I want the largest smoothie, or I want a very big smoothie, for example, it would, even though it's not like completely aligned to the product name of, let's say, large smoothie, it would still identify the correct product of the largest sized smoothie based on embeddings, right? Because they're close to each other in the vector
exactly
space.
Right. So because you're right here, because the inputs, the questions or the natural language prompts are like very similar, it could technically use the same query and then get the same expected result that it wants. So you said largest, biggest, and then like large, right? These three are very close, and in vector space you'll see them very close together. So we could engineer it so that every time the words are close together, it doesn't generate a new query, it just reuses what we have already done before.
Right.
Because like saves us time, and because prompting AIs can be very expensive.
You've begun a big AI project recently, Connect, and you've made a prototype. Why is a prototype important?
A prototype just basically proves that the concept is feasible, And when you create a prototype, you're not exactly working on scaling it and building the infrastructure for it. So prototype can be just run locally with a bunch of test results that you, or a bunch of tests that you run by yourself on the fly, locally on your machine, without having to deploy it anywhere on the cloud. Whoa, big words, right? Yeah.
And how has that prototype gone so far?
Yeah, it's gone pretty good. We had a couple test runs. Last time I touched it, it was like the outputs weren't as nice as I would have wanted them to be, but we're still working on it.
Why do you think AI is not replacing your job?
AI is not going to replace your job. It'll make your job a lot easier, and then probably make you more efficient, depending on what you do.
Oh well, as a developer.
As anything really, except for like if you're talking about like manual labor, then it's like a whole other thing. Unless you get autonomous robots, then it's a different thing, right? But it's the same idea. It'll just make you a lot more productive, allow you to ship faster, build prototypes within a span of a day or so. But then improving and refining those is up to how good of a developer you actually are, not based on how good the AI is.
Okay.
The AI can do stuff, but you just gotta be able to use it well, right? So it's a tool that you wield with your hand.
What do you like about working at Tierra? Oh,
the people here are amazing, man. Just the vibe here is immaculate. Not this guy. Nah, just kidding, bro. Everybody here is like super nice. We just get along a lot well, and we don't have this unnecessary games where it's like ego play or just like I'm using you to get to something that's greater. Like it's just nonsense, right? So alhamdulillah, there's none of that. I'm actually like very happy at how you can be productive. Tierra has shown me that you can be productive and enjoy your work. Because before I was productive, but I did not enjoy what I was doing. A big part of that enjoyment comes from the people. So alhamdulillah, we're blessed to be here in this wonderful company.
All right, we'll put the gun down now.
Put the gun down. That's all from my heart, bro.